Hey guys, this is Mr. Grice for Algebra Unit 9.5 Notes. Today we're talking about graphing absolute value functions. Our learning target today is to be able to graph absolute value functions that involve shifts and reflections. So, before we get started, let's have a little reminder. What's an absolute value? Okay, the absolute value is the distance a number is from 0. Okay, and whenever we're talking about the word distance, we're talking about a positive number. So the absolute value of 3 is 3, and the absolute value of negative 3 is 3. Okay, so when we're talking about just basic absolute value, that's what we get. So let's look at the parent function. Okay, once again, this is something that you should memorize. So absolute value of negative 2, 2. The absolute value of negative 1 is 1. Okay, and you guys can fill out the rest of it. The absolute value is blah, 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 blah. The absolute value of 0, 0. Absolute value of 1, 1. Okay, now let's graph this. So 0, 0, 1, 1, 2, 2. The other side was negative 1, 1, negative 2, 2. What is this making? It's kind of like a parabola, but it's not. This makes a V shape. Okay, it's a perfect V. It's not lopsided. So when you're doing your graphs, make sure you draw your graphs. Mine was just a little lopsided. I'll fix it to make it a little bit better. We want them the exact same. Okay. Other points, the arm, well, yeah, the arm should always be the same length. Make sure it's not lopsided, and it's always going to be a perfect V shape. Okay. Now, what's the pattern? Okay, the pattern was up 1, over 1. And then the second one, up 1, over 1. So that's the parent function. Now let's look at the transformed function on the right. What can you tell me? Is it reflected? Yeah. Okay, this is reflected. It's reflected over the x-axis, and that's because of the negative 1. It's going the opposite way as our first one. That means it's reflected. All right. What about shift? Did we have to shift to the right or left at all? Well, yeah, it shifted 1 to the left, so it went left 1, and then did it go up or down at all? Yeah, it went up 2. All right, so the up 2, that's because of the positive 2, and the left 1, that's because of that positive 1. Okay, the vertex is the same thing as what we've been talking about with quadratic functions. Okay, so that's nothing new. The only thing that's really new is the shape. So let's compare the given function to its parent function, f of x equals the absolute value of x, by describing any shifts or reflections. Use the vertex to help you describe the transformations. Now, when we're talking about the word transformation, we're talking about shifts and reflections. That's what that is, okay? So, number 1, is the reflection over the x-axis, yes or no? No, because up front, in front of it, it's positive. So if it's positive, no reflection. All right, what's our vertex? Just like before, we're going to take the opposite, and this stays the same. Okay, opposite, and that stays the same. So the opposite of +2 is -2, and then that -5 stays the same. And that tells me my horizontal shift is related to my x point in the vertex, so that's telling me that I have to go left 2, and then the y tells us to go up or down, and since it's negative, it would say to go down 5. Okay? Why don't you, let's do one more together. So, is there a reflection? Yes or no? And we're looking up front. Yes. Okay, our vertex. It's going to be 4 and 7. Okay, remember this is where we get the 4 from. +7. +4 tells me that we need to go right 4, and that +7 tells us that we need to go up 7. Okay, number 3. Why don't you try it on your own? Pause the video, and good luck. Okay, there's a reflection because there's a negative in front of the absolute value. My vertex is 0, 6. Horizontal shift is none, and our vertical shift is up 6. Okay, let's move on down. So graph each function and identify any shifts or reflections. And remember, that is what we're talking about. The shifts and reflections are our transformation. Okay? In case you want to remind yourself. Also list the function's domain and range. Okay. So reflection, yes or no? No. What's our vertex? So we gotten +5 and -4. So the +5 tells us that we have to go right 5. And the -4 tells us that we're going to go down 4. So 5, -4 is where we're starting. And then we follow the pattern up 1 over 1, up 1 over 1, up 1 over 1. And if you're going to do 3 points going to the right, make sure that you do 3 points going to the left. We don't want it too small, and we don't want it lopsided. Okay? And there, that gives us a good idea of what our graph's going to look like. So find the value of f of 7. So I'm going to go to 7 right here. And I'm going to go down. And when I go to 7, my point is at -2. Now, our domain is going to be the same thing as a quadratic because as our x values, there's no limit on them. It gets wider and wider and wider and wider and wider. Okay? So even though this stops, those are just going to keep going and going and going. So our domain is all real numbers. But now our y is related to the vertex point. Okay? Because if we look, that value is -4. Does the graph ever go below -4? No, it's always above -4. Okay? So for our range, we would say that y is greater than or equal to -4. All right, let's go ahead and flip it over. Number 5. First thing, is there a reflection, yes or no? Okay, there's a negative out front, which means yes. Our vertex, what's our vertex going to be? Well, there's a +3 inside, and if it's positive, I'm going to take the opposite of what's inside. And then our vertical shift, Our y point, there's nothing out here. So remember, that's like saying plus 0. So horizontal shift, we're going to go left 3. And the vertical shift is none. All right, let's go ahead. So negative 3, 0. Was it reflected? Yeah, so when it's reflected, I'm going to do the opposite. Down 1 over 1, down 1 over 1, down 1 over 1. Okay, so I drew a couple of points each direction. And just like we said, it makes a perfect V. So at negative 4, right here, we're at negative 1. Our domain, the domain for an absolute is always all real numbers. But our range, remember, our range is really connected to our vertex, okay? So is it y greater or equal to 0 or less than or equal to 0? Okay, the reflection tells us that it's less than or equal to 0, okay? All right, number 6. Why don't you guys pause the video and see if you can do this one all on your own. Good luck. Okay, there we go. So there's a reflection. The vertex is 1, 7. We had to go right 1, up 7. At f of 3, we're at 5. Domain is all real numbers, and our range y is less than or equal to 7. Okay, let's look at number 7. Is there a reflection? Yes or no? No. What's our vertex? Vertex is negative 1, negative 6, which tells us we have to go left 1 and down 6. So let's go ahead and graph. What type of graph is this going to make? What do you think? Ooh, we're being tricky. That's a square right there. This is a quadratic graph. So negative 1, negative 6. So we got to follow the pattern of up 1 over 1, up 3 over 1. Okay. We will be reviewing some of this stuff, guys. Okay. So make sure that you are paying attention to the equation. All right. So at f of 0, we get negative 5. And then our domain, I just mentioned this a second ago. Domain of a quadratic is all real numbers. And then our range, y is greater than or equal to, because our y values are going up, negative 6. Okay. Let's look at the bottom part where it says challenge. These are the type of questions that you would see on the harder version of a quiz. Okay. It's asking you to write the equation in each graph, not to tell me what type it is. Write the equation. Okay. So the things that we have to ask ourselves when we're doing this is, what's the shape? What's the vertex or the initial point? And is there a reflection? So let's take a look at the first one. This is a absolute value. And our vertex, what we care about right now, is at 2 comma negative 1. So we're writing it. Is there a reflection? Yes, so we have to put the negative sign. There's an X. And if our vertex is positive 2, that means up here it needs to be negative. And then the negative 1 comes to the back. Okay? What about B? B is a quadratic. Good. What's our vertex? Okay, the vertex is -2, +3. So you can pick any letter, that doesn't matter. Is there a reflection? Yes, so that's got to be negative. Okay, that -2 comes here and it's the opposite, so it's +2. Don't forget the square because we're talking about a quadratic. And then +3. That's where the 3 goes. All right, the last one, this is a square root. So for square root, we need our initial point, and our initial point is -3, 1. So remember that -3 comes inside, and we take the opposite of that, and then the 1 on the outside is +1. Okay? So remember when you're doing that, you're asking yourself, what's the shape? What's the vertex or the initial point, and is there a reflection? Okay? If there's a reflection, you better be putting that negative sign out front. All right? Well, guys, that's going to be it for Unit 9.5 notes. We are going to be taking a quiz over the 3 types of graphs tomorrow, so good luck. If you have any questions, please come see Ms. Carranza or myself. Otherwise, this is Mr. Grice signing off. Thanks for watching.